Hi friends, welcome to ugcnet. In this video, we'll be going through some of the previous year questions based on the phases of a compiler. And I have taken questions from the past 4 years, that is from 2018 onward. So here you can see that question from phases of a compiler, this question is repeatedly asked many times. So I hope this is very important question as well as it's very easy question also. So you can score very good marks from this. So the first question is, for a source language statement, a is equal to b star c minus 2, where a, b and c are float variables. That is given that the variables a, b and c are floating variables. And here it's given that star and minus represents multiplication and subtraction on some data types. That means they are the normal multiplication and subtraction. Show the input and output at each of the compiler phases. So the question is, we have to consider this given statement. One assignment statement is given. We have to consider this statement as our input to the compiler. And we have to show the output of each and every phases of the compiler. What the output will be for this statement when we give this statement to the compiler. At each phase, how the statement will be converted. That we have to show. And the question comes as a 4-mark question. And this was asked in April 2018 paper. Okay, and this phases of a compiler is again asked in May 2019. But here only the theoretical portion is asked, and it's a 5-mark question. Okay, now the third question, look here, explain the working of different phases of a compiler, illustrate with a source language statement. That means you have to take a statement as example, just like this statement, a is equal to b star c minus 2. Just like this statement, you have to consider one statement and you have to show the output of that statement in each of the phases. So while you explain about the different phases of a compiler, you have to show the output of this statement in each and every phase. Okay, and that's also asked as a 5-mark question, and it was asked in the question paper December 2019. And in 2020 also the same question was asked. Trace the output after each phase of the compiler for the assignment statement a is equal to b plus c star 10 if variables are given as float type. So here also it's given that the variables a, b and c are floating values. So just like the first question, here also they have given one assignment statement and we have to show the output of this assignment statement at each phase of the compiler. But here the question is asked as 6-mark question. Okay, and this was asked as the supply question in the year 2020. So here you can see that in each year 2018, 2019, 2 times, okay, 2020. So in all the question papers, one question comes from this phases of a compiler. So I hope this time also there is a chance to ask a question from phases of a compiler. And in this video, I'll be showing this first question. And I hope after learning this first question, you will be automatically able to do the fourth question. Second and third is the theory question, and that portions I have already covered in the previous 2 videos. I'll put the link in the description so you can check it out. So let's move straight towards the first question. So the input statement given was a is equal to b star c minus 2, and it was given that a, b and c are floating values. A, B and C are float values. Okay, that's important. Note it. Okay, so we know that the compiler has different phases, 6 different phases. The first 4 phases are the front end or the analysis phase, that is the lexical analysis, syntax, semantic and intermediate code generator. And the second part of the compiler is the synthesis part. It consists of 2 phases, that is the code optimization phase and the code generation phase. So let's move on to the first phase of compiler, that is lexical analysis. And we know that the role of lexical analyzer is tokenization. That means when we give the input a is equal to b star c minus 2 to the lexical analyzer will convert this stream of characters into stream of tokens. So the stream of characters will be converted to a stream of tokens. So the stream of characters here are a is equal to b star c minus 2. So when we convert this to tokens, we know that a is an identifier. So it will be converted as id, 1. I hope you already know why I write like this. If you don't know, please watch my previous video. Okay. So the first lexeme is A, and A is an identifier. So we converted it to the token identifier. The second lexeme is equal to. Equal to is an operator. So we put it as it is. Now the third lexeme is B. So B will be converted to the token identifier. So the token identifier will be written as ID, 2. That is the second identifier. A is the first identifier and B is the second identifier. Okay, now the fourth lexeme is star, and we know that star is an operator. So the star will be converted to the token star itself. The only thing you have to remember is for the variable names, we give the token name as ID and we give one value also. Actually, this is a pointer to the symbol table, but just understand that for each of the variables, we give 1, 2, 3, etc. Okay, and for each of the operator, the operators are token operator, but here for simplicity, we give the operator itself as the token name. And similarly, for the constant values also, the numerical values, for that also for simplicity, we will write the token name as that constant itself. Okay. So here we have converted 4 lexemes A equal to B and star. 4 lexemes we have converted to their corresponding tokens. Now the next lexeme is C. C is an identifier. So we know that we have to write it as ID, 3, the token ID, and it's a third token. Okay. Next lexeme is minus. Minus is an operator. So we write it as minus itself. Let me just remove this line. Now the last token is 2, right? And we know that 2 is a constant. It's a numerical value constant. So we write it as 2 itself. So here we know that there are 1, 2, 3, 4, 5, 6, 7. There are 7 lexemes. These are the lexemes. Lexemes, tokens, patterns, everything I will be discussing in the upcoming videos. Okay, so there are 7 lexemes and we have converted these 7 lexemes into the corresponding tokens. These are the tokens. Okay, so we got 7 corresponding tokens, right? So the input A is equal to B star C minus 2, which was fed to the lexical analyzer, is now converted to a stream of tokens. So this will be the output of the lexical analyzer phase. Now let's consider the second phase of the compiler, syntax analysis. So now we know that we have given our input to lexical analyzer. Lexical analyzer produces tokens, and now these tokens will be given to the syntax analyzer. And what will be the output of a syntax analyzer? Syntax analyzer is also known as parser. Similarly, lexical analyzer is also known as scanner. Okay, so the syntax analyzer or the parser will produce a parse tree. So here in the second phase, the syntax analysis, the tokens that was produced from the lexical analyzer will be given as the input to the syntax analyzer, and the syntax analyzer will convert these tokens to a parse tree. Parse tree is simply graphical representation of these tokens. So in syntax analysis, we are not doing any extra calculations or something like that. We are just representing these tokens in the form of a tree. So here, the most important thing that you have to consider is you have to check for the precedence while drawing the parse tree. That means here you can see that there are 3 operators in our token, right? One is the assignment operator, 2 is the star operator or the multiplication operator, and the third one is the subtraction operator. Among these 3 operators, we know that the star or the multiplication operator have the highest precedence, right? So we have to consider the star operation first. Then comes the subtraction operator. So minus have the second precedence, and the least precedence is for assignment operator, that is equal to. Equal to is having the lowest precedence, right? So while drawing the tree, you have to consider the star operation first. So let's check. The star operator is done between the ID 2 and the ID 3, right? So what we have to do is ID 2 star ID 3. The star operator is performed between ID 2 and ID 3, right? So just draw like this. So the root will be star and the 2 children will be the ID 2 and ID 3. Always note that the intermediate nodes will be an operator and the leaf node will be identifiers. Okay, always remember that. Got it? So now we have done the multiplication operator and we know that the second precedence is for the subtraction operator, right? So here we have completed this much part, and now we have to consider the subtraction operator. Now we can see that subtraction is done with this portion and 2. So the left side of the subtraction, that we have already created a tree. right? So what we have to do? We have to create another tree with the root node as this subtraction operator, and this subtraction operator will also have a left and right child, and the left child is the left side of this operator. Left side is the this subtree, right? This will be the left side of the subtraction operator. So let me just rub this first. I'll draw it again. ID2 star operator, ID3. This was what we have done already, right? Now we are considering the subtraction operator. So for the new tree, subtraction operator will become the root, and the left side of the subtraction is ID2 star ID3. That is what we have already done in the previous step, right? So the left child will be that subtree, and the right side will be 2 here. Now also you can see that the intermediate node is an operator. There are 2 intermediate nodes. Both the intermediate nodes are operators, and the leaf nodes are identifiers. Identifiers or constants, whatever it may be. Okay. So we have now completed star operation, subtraction operation, and what is left? We have to do the assignment operation, right? So here in our token stream, we have completed this much portion. Now what left is the assignment operator. So what we have to do? We have to construct a new tree with the root as equal to. And here we can see that whatever we have done till now comes to the right of the equal to operator, right? So while we creating the new tree, the root will be the equal to or the assignment operator, and the right child of the assignment operator will be the tree that we have already created, right? So equal to will be the root node, and the right child of the root node will be the tree that we have already constructed. And we can see the left side of the assignment operator is ID1. So here the left side will be ID1. Now also you can see that the intermediate node, now we have 3 intermediate nodes, and all the 3 intermediate nodes are operators, and all the leaf nodes are identifiers or constants, right? So this is the parse tree generated, and this parse tree is the output of the second phase of a compiler, that is a syntax analysis phase. Hope it's clear for you, right? And just to check whether you have drawn the tree correctly or not, you have to just do it in order traversal. Look here, start from the leftmost side, from here, okay? So what we saw first, we can see ID1 first. So ID1, then what comes? Equal to, then here this subtraction we will not consider it now because we are considering the in order. So we have to go till the leftmost end. So here, this is the end. Now we saw ID2. Now we come here and we saw star. Then when we come here, we saw ID3, and we went back to subtraction, that is minus, and finally we saw 2. So let's check. ID1 is equal to ID2 star ID3 minus 2. ID1 means our A is equal to ID2 is our B star, ID3 is our C minus 2. So this is the input that we have first given to the lexical analyzer, or the first given to the first phase of a compiler, right? So we can say that our parse tree is correct. Now this parse tree will be fed to the third phase of a compiler, that is the semantic analysis phase. Semantic analysis. And what will be the output of a semantic analysis phase? It will be a parse tree itself, but that parse tree is known as annotated parse tree. So what's the difference between a parse tree and an annotated parse tree? In case of annotated parse tree, we'll be verifying the type of each identifier. Okay. So that is why I said in the beginning that A, B, C are float. So in the question it was given that A, B and C, all the 3 variables used here are float values. That means they are decimal values. But here the value 2, the constant value 2 is an integer. It's not a decimal value, it's an integer. So what we have to do? In the semantic analysis phase, the type checking will be done, coercions will be done. All those are explained in detail in my previous video. So after coercions, what we will do? We will convert this constant 2 to a decimal 2. That means we will be doing int to float conversion. So in the third phase, that is in semantic analysis phase, we will do a small modification in this syntax tree. So I'll show it in the next page. So the third phase is the semantic analysis. The input is a parse tree and the output will be annotated parse tree. So this is the parse tree or the input to the semantic analysis, and we have to convert it to annotated parse tree, right? So what we have to do? We have to convert this 2 into a float. Before that, let me tell you one thing. This parse tree is different from this one. Okay, ID1 minus 2 star ID2 ID3. I have seen many students drawing this parse tree like this, because what they do, ID2 ID3 they are multiplying and they are subtracting it with 2. But this parse tree is wrong. Remember, this parse tree is wrong, because here the equation will be like ID1 is equal to 2 minus ID2 star ID3. That is, A is equal to 2 minus B star C. This is wrong. What was our input? Our input was A is equal to B star C minus 2. In this first parse tree, you can say ID1 is equal to ID2 star ID3 minus 2. So while drawing this parse tree, remember to check the position of each child. You cannot draw the left child as right child and right child as left child. Both will give you different answers, okay? This I just told you for your information. I have seen many students in my college also drawing the tree like this. That's why I said it now, okay? So what we have to do now? We have to convert this integer value 2 to a float value. For that, we will use the function int to float. So what we have to do is, we have to take the constant 2 and apply int to float conversion. Now this tree has become annotated parse tree. So the only thing we have done in the third phase is we check the type of all the variables, and if it's given that all the variables are float and the value, constant value given is an integer, not a float value, in that case you have to convert that integer to a floating value, and for that conversion we use the function int to float. So now we can see that all the identifiers as well as the constant is now in float data type. That means all are decimal values, right? Now we can pass this annotated parse tree to the fourth phase of a compiler, that is the intermediate code generator. There are many types of intermediate codes, but here we will be considering the 3-address code. What's the specialty of 3-address code? In 3-address code, we will be storing the values or the temporary results in some temporary variables, say T1, T2, etc. And also in each statement, we will be doing only one operation, except assignment. That means in each statement, there can be only 3 operands at maximum. Okay. Don't worry, you will understand it when I write the 3-address code here. So here in this parse tree, annotated parse tree, this parse tree will be fed to the intermediate code generator as the input. So what it will do? It will look what operation will be done first. We will multiply ID2 and ID3. This multiplication will be the first operation that we have to perform. So ID2 star ID3. This value will be stored in a temporary variable T1. This will be our first step. So here in this statement, you can see that only 3 operands are used. T1, ID2, ID3. Apart from the assignment operator, we have taken only one operator here. We cannot perform multiplication as well as subtraction in a single statement. We can only apply multiplication in one statement and subtraction in another statement. Okay, that's the specialty of a 3-address code. Only 3 operands will come in a single statement, maximum 3 operands. So this will be the first statement in the 3-address code. The second statement, what we have to do? Here in this tree, we can see that there are 4 levels. This is our first level, this is our second level, this is our third level, and this is our fourth level. In the fourth level, there are only the leaf nodes. Okay, we are not doing any operations in the fourth level. The third level, we are doing 2 functions. One is the multiplication that we have already taken. Second is the int to float conversion. Second statement of the intermediate code will be this conversion, that is int to float of 2. We are converting the integer value 2 into a float, and this value should be saved into some other temporary variable T2, right? Now we can see that this much portions of the parse tree is saved in T1 and this much portion of the parse tree is now saved in T2. Now we have completed all the operations in level 3. Now we move on to the upper level, level 2. There only subtraction is to be performed. So what we have to do? T1 minus T2, right? T1 minus T2. This we will store in another temporary variable T3. Okay. So this much portion we have completed and now that value is stored in temporary variable T3. Now we move up to the top level and the only one operation is to be performed, that is the assignment operator. So what we have to do? We can see that ID1 is equal to T3. So we can simply write ID1 is equal to T3. So this is our intermediate code, the 3 address code. Okay, so here in each and every statement you can see that apart from equal to, we are performing only one operation. Here we have done the multiplication operation. Here we have done one function, conversion function. Here we have done one subtraction function, and here we are not doing any other function except assignment. Okay. So apart from the assignment operator, we can do only one operation, and you can see that in each of the statement we have used at most 3 operands only. Here we have used 3 operands. Here we have used only one operand and one constant. Here we have used 3 operands, and here we have used 2 operands. Okay. So this is the output of the 4th phase of a compiler. So now what we have to do? We have to give this intermediate code to the 5th phase of a compiler. 5th phase is the code optimization phase. Okay, now what is code optimization? Code optimization means we are optimizing the code. That means we are improving the quality of our code. We are improving to get a better code. So here we can see that this was our intermediate code and we are trying to optimize this code. So what we will do? We'll take the first statement. T1 is equal to ID2 star ID3. In this statement, we are not doing anything. So we will write that as T1 is equal to ID2 star ID3. We are not doing anything special to that statement. Okay. So this statement is done. Now let's consider the second statement. T2 is equal to int2 float of 2. So what we are actually doing is we are converting the value 2 to a decimal value. How can we convert 2 to decimal? We can just write 2.0. 2 is an integer, but 2.0 is a float value. This conversion will take some time, right? So instead of doing this conversion, we can directly write it as 2.0. So we can reduce the time taken for that conversion. We can eliminate that function used there, right? So this statement we can completely eliminate this statement. Instead of this statement, what will be stored here in T2? T2, the value will be 2.0, right? So we are skipping this statement. We are just eliminating this statement, and what we do is in the third statement T3 is equal to T1 minus T2. In this third statement, instead of T2, we can directly write it as 2.0. Getting the point, right? So we can write T3 is equal to T1 minus 2.0. I'll do some more modifications here. Right now, just understand that T3 is equal to T1 minus 2.0. Okay. Now coming over to the fourth statement. The fourth statement is ID1 is equal to T3. What is T3? T3 was the value obtained here, right? So that value we are assigning it to ID1. We are not doing any other operations here. We are just assigning the value T3 to ID1. So here T3 is given to ID1, right? But here, just look here. This is just one extra unnecessary step, right? Instead of writing like this, we can simply write ID1 here. Isn't it? We can just eliminate this third step and we can write the ID1 directly here. Isn't it? Just look here. T3 is equal to T1 minus 2.0. But this T3 is nothing but ID1. So instead of writing the T3, instead of using another temporary variable T3, we are directly giving ID1 there. Okay. Now this is our optimized code. So here you can see that in the first intermediate code, there were 4 statements. We have reduced that 4 statements into simply 2 steps, right? As well as we have removed this conversion, as well as we have eliminated the usage of another temporary variable. Here we have used 3 temporary variables, but here in the optimized code, we are using only 1 temporary variable. So finally, we have optimized the code to get a better code, right? Now the final phase of the compiler is the code generator. Here code generator means we are generating our target code. And we are considering the assembly code here. So what we have to do, the code generator will get this optimized code as input and it will then produce the target code or the assembly code as output. Okay. So what we have to do, we have to convert these 2 statements into assembly instructions, right? And we know that assembly instructions use registers. The values that are stored in these temporary variables and these identifiers, we will be loading those values into some registers and the operations will be performed between the registers only. And finally, the result that we obtained will be stored back to the identifier or the variable from the register. So what's our first statement? T1 is equal to ID2 star ID3. That means we are doing a multiplication operation over the variables ID2 and ID3. So in order to do that, first we have to load the values of ID2 and ID3 into some registers. So for that I am using register R2 for ID2 and R3 for ID3. Okay, and the instruction is load, LD for load, and F, LDF, F to denote that these variables ID2 and ID3, these variables or the identifiers are floating values. So LDF, load float values ID2. So this statement, the first statement means that we are loading the value of identifier 2, ID2 will be now loaded to the register R2. Similarly, we have to load the value inside the ID3 to some register, and we have taken some register R3 for that. So load float value ID3. So here we are loading the value of ID3 into the register R3. Okay. Always remember one thing, the first argument that comes after this instruction. Here the instruction is load, LDF. So after this instruction, whatever comes first, this will be our destination. We will perform the operation and we will store the result back to this destination. Okay. So in the first statement, we are loading the value of identifier 2, ID2 to the register R2. And in the second statement, we are loading the value of ID3 to the register R3. Okay. You can choose whatever name you prefer. You can write it as R1. You can write this R3 as R2. Whatever name you like, you can choose. Here I just took R2 because it's ID2 and R3 because it's ID3. That doesn't matter. Okay. So now we know that the value of ID2 is in R2 and ID3 is in R3. So what's the next step? We have to do multiplication over these two variables. And the value of these two variables are in R2 and R3. So we have to perform multiplication over the register R2 and R3. So the next statement is multiplication. Mul over the floating values. So mul F. And what we have to do? We have to multiply the values inside the registers R2 and R3. So what will be done here? The register R2 and R3 will be multiplied and the result will be stored to the register R2 because this is our destination. So the value that was stored in T1, that value will be now in the register R2. Okay. So what's our next step? We have to perform T1 minus 2. And we know that the value of T1 is now in the register R2, right? So what we have to do? We have to subtract 2 from the register R2, right? So the next operation is subtraction. Sub, it's a floating value. So sub F from R2, we have to subtract 2. 2 is a constant, so we denote it as hash 2.0. This hash value just represents that this is some constant value. And remember, you have to write it as 2.0 itself because we are taking it as a float value. Okay. So here what we are doing? We are subtracting 2 from the register R2 and we will be storing that result back to register R2 itself. So our final result is now inside the register R2. Now what we have to do? We have completed T1 minus 2. This operation we have performed and now we have to store the result to the identifier ID1. And we know that the result is now inside the register R2. We have to store the result that is in register R2 to the identifier ID1. And for that we use the instruction store ST and F to denote that it's a floating value. So store float value. What's our destination? We have to store the result into ID1. So our destination is ID1. And from where we have to store that value? The result is in register R2, right? So R2. So this is our last statement, that is we are storing the value inside the register R2 into our destination ID1. So that is a final answer. This is the target code that we generated. So here you can see that our input statement A is equal to B star C minus 2. This was our input statement, right? This statement was given to a compiler and it passed through the 6 different phases of a compiler and we have seen the output or the conversion of this statement at each of these different levels, and finally the output of a compiler, that is our target code, is generated. So this single statement is converted to this 5 assembly instructions, right? And that's our answer. I hope you understood. So the assignment to you is you have to do this 4th question. This is a similar type of question. The first question we have done. And now this fourth question. This is a similar type of question. It was asked in 2020. And here the instruction given is A is equal to B plus C star 10. And here also it's given that all the variables are float type. Okay. This is just similar to the one we have already done. Here what you have to do, you have to perform the multiplication first. Also you have to convert this 10 to float into float of 10 to be done. And then you have to perform the addition operation and finally assignment operation. Finally the result will be saved to A. So this is your homework. I hope you all will be able to do that. And if you have any doubt, you can send them through mail. And my mail ID is ejumendo2016@gmail.com. You can send your queries there. I'll get back to you. You can even mail me your answers. I will check it out and tell you whether it is right or not. And I hope everybody will be able to do it. If you understand my lectures, you will be able to do it. So see you soon in the next video. Thank you.